Dear students, I am Meenakshi, Assistant Professor from Chikbalapur College. In this session, I will discuss about friction in detail. That is the meaning of static friction and the kinetic friction. In last session, already we have learnt about what is meant by friction, how it affects in our daily life, and also types of frictional forces. There are two types of frictional forces. One is static friction and another one is kinetic friction. So here static friction, it appears as a gripping force while walking or while running. Okay, without minimum frictional force on the road, you could not walk and also you could not run. You may slip. Okay, without friction, without minimum frictional force, if you want to walk on road or run on road, you may get fall down. Similarly, while driving motor vehicles, the static friction between the tires of the vehicle and the road, okay, without that static friction force, you could not run the vehicle. Even to stop the vehicle or even to start the vehicle, minimum frictional force is necessary. Therefore, while walking or running or to drive any motor vehicle, minimum frictional force is the necessary thing. In both the cases, that is in case of static friction and kinetic friction, coefficient of friction is defined as follows. In last session, already it is proved that frictional force acting on the body is directly proportional to normal reaction force. Therefore, F is directly proportional to Fn. Replace that proportionality by some constant mu. Therefore, mu can be written as F by Fn. That is, the ratio of frictional force versus normal reaction force is called as coefficient of friction. So this coefficient of friction, it is having some value, may be equal to 1 or less than 1 or greater than 1 depending upon the pair of contact surfaces. Coefficient of static friction, it is denoted by the letter mu s. It is given by ratio of maximum force of static friction to the normal reaction force. That is mu s is equal to F by Fn. Similarly, coefficient of dynamic friction or kinetic friction is also defined by the relation ratio of frictional force to the normal reaction force. It is denoted by the letter mu k. It is denoted by the letter mu k. Observe here one thing. Coefficient of kinetic friction is always smaller than that of static friction for the given pair of surfaces. And one more thing here, we need to know about angle of repose. What is meant by angle of repose? Here observe the diagram. We have taken two surfaces OA and OB. OB is inclined at an angle of phi with respect to OA. On OB, some object is kept at equilibrium condition. Object is kept at equilibrium condition. Here, on object on the surface OB, frictional force is acting, weight of the object is also acting, and normal reaction force is also acting. Frictional force, weight of the object, and normal reaction force. All the three forces are acting on the object. Here, what is meant by angle of repose? Angle of repose means just the minimum value of the angle at which the body just starts slide down. is called as angle of repose. It is denoted by the letter phi. Angle between OA and OB. It is the minimum value of angle at which the body just starts sliding down. It is called as angle of repose. Here I have listed out some for different pair of surfaces the values of static friction and kinetic friction. Steel on some steel surface, aluminum on some steel surface, copper on some steel surface. Observe the values for the given pair of surfaces. Here observe mu k, that is static frictional value, is slightly greater than that of kinetic friction value. Next, here I will explain the relation connecting between coefficient of friction and the angle of repose. That is coefficient of friction mu, how it is related with angle of repose phi. Observe the diagram clearly. Here we have taken AC and AB, the two surfaces. AB is inclined at an angle of phi with respect to AC. AC is the horizontal surface, AB is the inclined surface. On inclined surface, some object is at equilibrium position. Now, the weight of the object mg, it is acting along downward direction. Normal reaction force is acting along the direction R, and frictional force acting on the object, that is along AB. Now, in the diagram here, two axes can be considered. Along AB, consider it as x-axis. Along R, consider it as y-axis. Now, resolve the weight of the object, that is mg, into two components, one along x-axis and one along y-axis. Along x-axis, the component of weight is mg sin phi. Along y-axis, the component of weight is mg cos phi. Now, along x-axis, the maximum value of frictional force acting on the body is given by Fs maximum is equal to mg sin phi. Along y direction, the normal reaction force acting on the body is given by mg cos phi. Now take the ratio between these two, that is Fs maximum versus Fn. It is given by mg sin phi versus mg cos phi. Mg get cancelled. Ratio of sin phi versus cos phi is equal to tan phi. It is denoted by the letter mu because the ratio of static frictional force to the normal reaction force is defined by the letter mu. This is called as coefficient of friction and it is related with the angle of repose phi like this. That is mu is equal to tan phi. Thank you.